Hi guys, welcome back. Just a quick video I wanted to make. This is my Grundig UV4 multimeter, or voltmeter, however you want to call it, which I bought last year, and I made a video about this meter also on my channel. I can link it in the description, where I basically went through it and checked if everything was working correctly. Now I have to say I absolutely love this meter for three main reasons. First reason is the size of the display. It's incredibly large. Let me show you, compared to my oscilloscope, it's the readable, or the part of the display which covers the meter is about the same size as the display of my oscilloscope. So it's pretty big. Now for reference, if I would take this Blu-ray case, see, it's almost the identical size of the display. So yeah, it's pretty huge. Now I figured, since it's a German meter, I'll take a German film. So great film and huge display. So that's the first thing I like about it. Second thing, scale indicators. So depending on which scale you select, for example, if you select the 3 volt range, see, it indicates which dial you should read. Now that doesn't seem pretty impressive, or that doesn't seem like a lot, but I can tell you that's just so nice. I mean, it's definitely not the only meter that does this. There are other types or other brands that do this as well, but believe me, this is just so convenient. How many times with an analog meter have you asked yourself, when you push a button or when you are measuring something and then you look up to the meter, it's like, okay, which scale was I at again? Okay, right, this one. Every time, again and again. You don't have to do this with this meter. It automatically indicates the scale, which is, well, a great feature. See, so this is the ohms range, and those are all the voltage ranges. Simply fantastic. Third thing, that probably will not seem that spectacular, that it's the least of the three things I liked, is the center zero. So if you enable this function, then you can center the meter like this, and then you have 0 volts basically in the middle, and if you have a negative voltage, the meter goes to the left. If you have a positive voltage, the meter goes to the right, and that's very convenient for balancing an FM detector. But there are plenty of other meters that do this as well. But those are the three things that I like the most about this meter. Now there is one thing which is quite a significant drawback, or a very big drawback, let's say. And that is that it cannot measure AC. It can only measure DC. Maybe if you're looking at the screen and you're maybe screaming at your screen like, Christophe, you're blind, there is a AC function over here. Well, that doesn't do anything. See, originally, when you bought this meter, and if you wanted to measure AC, you had to buy an extra accessory. It's a test probe. I believe it's an HK4 test probe from Grundig that you could buy, and then you could measure AC. So the test probe plugs in over here in this socket, or this connector. See, it says Tastkopf probe, and then, yeah, AC volts. So you would plug in your test probe over here, and then you could measure AC with that test probe. Now what that test probe simply did was rectify the voltage. So then the voltage that the meter sees is still simply DC. The rectification is done inside the probe. Why they did this is quite clear, because they wanted to support also higher frequencies. So this test probe, according to the specs, went up to 30 megahertz fully linear. Higher than 30 megahertz, I think they claimed it could go to 100 or 300 megahertz, but then you would have to factor in a couple of dB of losses. But in any case, in this way, when you immediately rectify the voltage in the probe itself, you avoid, well, reflections and signal losses on the line towards the meter, right? So that is the original idea. But the problem is that these probes, they seem to be made out of unobtainium, because I haven't seen yet a meter that is sold with this probe included. So if you pick up a meter like this, you cannot measure AC out of the box. The probes are extremely difficult to find. So that's why I built this. This simply has inside this little black box more or less the same circuitry that was in the Grundig original probe to rectify the voltage. This one I can simply plug in here into this socket, and then here I have a BNC connector to which I can connect any test cable that I have for connecting this to the circuit that I'm testing. Now this connector here might look weird to you, but it's not weird at all. It's nothing exotic. It's simply a 3-pin DIN connector. Now these connectors, they were used often in audio equipment. For example, see, I have here a DIN cable. It's a simple audio cable with a 3-pin DIN connector. And this one has only one, well, it has the shield plus one additional wire inside. I think these were mainly used for mono applications. So the stereo variant, if I recall correctly, is the 5-pin socket, but this, the 3-pin, they were pretty common. And if you look here at the edge, there is like a screw thread on the inside of the connector. So originally, the connector that was used by the test probe had a screw thread on the outside of the connector. And I happen to have one like that over here. See, this is also such a connector. It only has a 2-pin socket though. It doesn't have 3 pins, but it does have the screw thread on the outside. See, so you can plug that in. Of course, I have only one of the, or the 2 of the 3 pins connected, and then you can screw this in. See, and it locks in place, and now your connector is nice and stuck, basically. Now, if it's a good thing or not, I'm not convinced. If I accidentally plug my cable or pull my cable, I maybe just want the connector to unplug instead of pulling on the entire meter. But this is what the original intention was. Now, I'm not going to use this one for 2 reasons. One, it only has 2 pins instead of 3. And 2, I have the matching female connector as well. So I don't want to orphan these. Because if I would use, see, now I have a nice extension cable. It's unused, I think. I don't think this has ever been used. But it's probably for a microphone extension cable. But I don't want to orphan the female side just by using this for a simple, well, rectifier circuit that I was going to build. So I just used the standard 3-pin DIN connector. And the advantage of this is also you cannot plug it in upside down, right? So if you have all 3 pins available. Now, let's try to find out which of the 3 pins we actually need to connect to. Now, that's actually quite easy to reverse engineer. You just take another multimeter, you put it on ohms mode. And when you put your multimeter on ohms, then the multimeter applies a very small voltage on the probes just to read the resistance that you are basically measuring. So we're going to do that and put here the multimeter here on, we need to put it on AC, because these switches, what they simply do is they select which, well, input connector you're going to use. That's the only thing that they do. Well, I mean, the difference between just positive DC voltage, or the AC simply switches between these two buses. For example, if I put it on positive DC voltage, and if I now put my multimeter probe here on the ground, let's put it maybe on the 3 volt scale, and then here on the input, see, then you can see that we read about 0.6 volts. Let's put it on the 1 volt scale. Yeah, 0.75 volts, 750 millivolts. See, if I switch to AC, it completely shuts off because these inputs, they are now disconnected, and now this plug is connected. So I already figured out which are the pins that I need to connect, and this is the ground one, the one in the middle, it's the ground, and the top one, that's the signal, the positive. The bottom one is simply not connected at all. And see, so if I just go back to DC volts, it shuts off this input. So that's basically the only thing that we are doing here. What we could also have done is not use a DIN cable and just use 2 banana cables or banana plugs and use these as an input. But then you'd have to measure here on the DC setting, of course. And that makes things a bit weird because you could then also use the negative DC volts and the center DC volts to measure AC, which don't make sense. So I prefer to do it like this. Now, keep in mind that if you salvage a connector like this from a cable like this, from an old audio cable, then probably these are going to be wired the other way around. Let's see, so wait, let me bring this in a bit closer. If I can focus here, right, there it is. See, so if you plug in it like that, then you can see that the ground is indeed, or the shield is indeed connected to the center pin, but the signal is connected to the bottom one. So what you need to do is you need to swap that signal to the top pin. And then you're good to go. Now, the circuit that I put here inside this box, it's quite simple. It is based on, well, the circuit that Grundig originally put in their probe, but also it's quite a common circuit that is used often in RF probes or in detector probes. It's simply a rectifier circuit. Let me show you. So first, let me open this thing up. Let's take a screwdriver. And I'm just gonna open this box up, and then you can see what I put inside. Now these enclosures, I got them on AliExpress for, yeah, I just flung a screw underneath the multimeter. That's great. Try to do that again, you'll never succeed when you want to do something like that. Now, these enclosures, I got these on AliExpress for, I don't know, I think like 1.5 euros or something. And the nice thing is they are fully made out of metal, so they are a bit acting like a shield as well. Now did I took out the wrong screws. Oh, that's typical. I did have quite a struggle to put it back together, so I hope that I will not have to put everything back together again. Yeah, see, there we have it. We're going to have a look at the schematic in a second, but I just made a prototype PCB and soldered in all the components. You can already see a trimmer pot to, well, basically fine-tune the circuit a bit. But there's not a lot to see here. Let's have a look at the schematic. Okay, so this is the schematic. As you can see, it's extremely simple. Now, the original schematic by Grundig did not have any values of any components, so I just yeah, took some things as a guesstimate, let's say. You can probably change some of the values. It doesn't make a lot of difference. For example, I don't really know why I took 330 nanofarads here. You could probably also just take 100 nanofarads. I don't think it's going to be a big difference. What is important is here these diodes, so these act as the rectifier. I have here 1N34 germanium diodes, simply because they, well, have a low voltage drop, so you'll lose not that much of a voltage. You could probably also use Schottky diodes here, but I use germaniums because they seemed fitting in this, or, well, they seemed period correct in this application. And then I have here a 1 meg ohm resistor and okay, what the heck did I drew here? This has to be like that. That was not correct. Anyway, I have here a voltage divider between a 1 meg ohm resistor and a 560k resistor together with a 100k potentiometer, just to fine-tune the output a bit, and then you can more or less calibrate the well, the probe. Not that it's super necessary because I'm not chasing high accuracy here. I just want to measure the amplitude of the signal relatively. If you're aligning a radio, you don't really care about the absolute values. You just want to peak the output. So it's not that important. But this way you can fine-tune it. I used a 10-turn pot here, or maybe even a 20-turn pot. I don't know what this is, what I put it there, simply because I had it laying around. It's also not really necessary and probably also quite overkill. Now, as you see, it's quite simple. It's a rectifier and a voltage divider and some capacitors. And it works pretty well. Let me show you this thing in action. Okay, so I closed it back up again, apart from that one screw that went underneath the meter that I need to find somewhere, but I'll do that after the video. Let's plug this one in and let's put it on AC volts. And then let's turn on my signal generator. Now you won't see the screen of the signal generator, so you will have to trust what I'm saying. So what I want to do here is I want to have it more or less accurate. These cables are not the best. I think it's also this BNC connector, which was El Cheapo. So I probably need to change that for a better BNC connector. Anyway, what was I saying? I want this to be more or less accurate in the audio range. So from 50 Hertz to 20 kilohertz, something like that. Outside that range, I don't really care because I will not be measuring those frequencies anyway. So I will, well, let's start at 1 kilohertz because that's a tone that will probably be used quite often. So I have now on the meter 1 kilohertz. Let's set it to 3 volts, or let's 5 volts. 5 volts RMS, and let's put this here on the scale of 10 volts and enable the output. And see, it's almost 5 volts. Did I zero the meter correctly? It could be a bit lower, but not much. This is 0. Yeah, see, it's near as damn it 5 volts. If I go to 6 volts RMS, see, it's also slightly high. So I could now adjust the potentiometer to try and get this more correct. But the thing is, the meter is also not perfectly fine. So if I go to 3 volts RMS, sorry, this was 2 volts RMS, 3 volts RMS. See, there it's slightly below 3. If I now go to the 3 volt scale, it's slightly above 3 here on this scale. So the scales of the meter, they are not all correctly calibrated. and I just bumped this wire again. So these are, well, it's close enough. If let's go up just to be out of curiosity. I'm just going to go down here to, let's take 1.5 volt RMS. So it should be over there. It's almost spot on. Now let's increase the frequency. Let's go to 10 kilohertz, for example. See, it's not budging. 20 kilohertz, perfectly fine. Let's go to, and I think we will see a slight impact there. Let's go to 100 hertz. See, there it's slightly dropping. So let's say below 100 hertz is not that linear anymore. Let's go to 50 hertz. You can see a drop, but still not really a big drop. 50 hertz, still quite okay. Let's go to 50 kilohertz, and then we can try to find the limit of this thing. See, it's still nice at 1.5 volts. 100 kilohertz. Nothing changes. 200, 300, 400. 500 kilohertz. Nothing changes. 1 megahertz. Still pretty good. 5 megahertz. 10 megahertz. My meter can only go up to 30, so this is 20 megahertz. See, there it's not linear anymore, I guess. See, this is 10 megahertz, that's 20 megahertz, 30 megahertz, and there it goes off the, well, outside the range of what you could say is acceptable. So, well, let's call it 20 megahertz as a decent result. I think that's fine. I think that's perfectly fine for what I want to do here. I think it works great. And as I said, it's not going to be an exact tool because the meter is also not exact. If I want to measure exact voltages on a certain high frequency, I'll use the scope instead of the meter. But this is perfect to align a radio and to measure an audio tone and then to peak the radio and see nicely when the voltage is increasing, when you are fine-tuning the different stages of the radio. So yeah, I think this is something that you can easily build yourself if you have such a meter and you are bummed by the fact that it cannot measure AC. If you were like me and you didn't even check that before you bought the meter, you just saw, oh, it has an AC symbol on the dial, so it must be able to measure AC, and then when you start using it, you were a bit disappointed that it cannot measure AC out of the box. Just build something like this. Some people also build or add it inside the meter itself, on the inside of the socket, but I don't like to do that. This completely avoids changing the inner circuitry of the meter. I don't want to mess with or customize the meter itself. It's always, well, what happens if you pass this device on to someone else? Then they need to start reverse engineering everything that you changed in the circuit and all these things like that. I want to avoid it. And this way you can perfectly avoid changing anything in the circuitry. You just plug this in, and then you can use your favorite test lead. You can also use something else than BNC. You can use banana plugs as well. Doesn't really matter. Just do whatever you please. And yeah. Now, just by this simple tool that it took me a while to build, but it's very easy to design. And just with this simple thing, now this meter will get a lot more use than it has today. Okay, that was this video. That was a quick one. I hope it's a quick one. I just realized here on the screen of my camera that I've been ranting for way too long. So thanks for watching, and I'll see you in the next one. Take care. Bye-bye.